The topic for today, guys, is to add expressions. I'm going to write in here, add expressions. And we start with the example number 1. In the example number 1, we need to add expressions using properties. So we start using the properties to add, in the example 1, add expressions using properties. Okay, so if we read the example, Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after M months? So the number of months are going to be represented by the variable M. We can see the pictures we have of the right part. Rudy's Rocking Climbers, $65 the initial fee, and $40 the monthly fee. Okay, this is the cost for paying the Rudy's Rock and Climbers. And the other one, Ace Health Club, the initial fee is $80 and the monthly fee is $50. If we use bar diagrams to represent this and write the expression for the cost of each club, remember, we relate the variable with the monthly cost that they are talking you about, okay? And the initial fee is an additional cost, so we only add to the expression that we have with the variable M. So for example, in the Ace Health Club, 80 is the initial fee plus 50 times M or 50M, $50 each month. So the M, remember, is relating the variable for the months. And in the other one, Rudy's Rock and Climbers, 65 plus 40M, you have the same. 65 is the initial fee and 40 multiplied by the variable M is the 40 multiplied by the variable that represents the months that I don't know how many months they are. So we express this using the variable. Now we can add the expressions to find the combined cost, okay? This is the important part that we are going to learn, how to learn the, how to add the expressions by using these properties. Remember about the properties, commutative property, associative property, that kind of things. Okay, so I have two expressions. I have the first one, 80 plus 50M, and I need to add this with the other expression, 65 plus 40M. These are the two expressions I have. I can use parentheses to separate, okay? Only to see this in order, I can use the parentheses to separate. And now what we obtain two terms that we can add. You can add this term with this one because they both have the variable M. I only need to reorder. And you can add the 80 with the 65 because any one of them has any variable. Remember, I can add or subtract when the terms are similar, okay? Remember. Then I can move 80 plus 65. This is for the terms that doesn't have any variable. Now plus, and I'm going to add the terms that contains the variable M. 50 plus 40. 50M plus 40M. And what property is this? The associative property. Use the associative, commutative, and associative property. Or we can write in here using, because we are using this actually. Actually, we are using the properties in this moment. So using the commutative and associative property, what we find? We find the result for this addition. In this case is 145 plus the value that we have using the variable m. In this case is 90m. This is the total that she is going to have for the number of months, okay? So the expression 145 plus 90 can be used to determine the total cost for the health club and the rock climbing gym after m months, okay? Remember that both of them are going to be multiplied by the variable m, that is the number of months, so you can relate it for both activities, the gym, the health club, sorry, and the, okay, health club and the rock climbing gym, okay, and then we can obtain the number of, the amount of money that she can pay. For example, if they are 50 months, you multiply 90 times 50. If they are 7 months, you multiply 90 times 7, okay? That's the idea. That you have the expression that you can use even if the number of months change. You can use the same expression. Okay. Then this is for the example number 1. In the example number 2, we can add expressions with more than one variable. Okay, I have one exercise below that says try it. In this case, they ask you, Sophia and Oli each deposit $120 to open a joint account. They each make monthly deposit as shown. What expression represents the amount in the account after M months? So how can I solve the other one? In the same way, they give you the expressions. Sophia's deposits 120 plus 150, and they give you that this is the number of months, plus, and I'm going to add the all his deposits, 120 plus 135M. So he is going to deposit $135 each month, and she deposits $150 each month. This is the idea of this. And 120 is the initial fee. They need to pay this to create the joint account. And this is what we need to add. Later, what we do, we separate, remember, the terms that has variable and the terms that doesn't have any variable. We learned about this in a few days ago, so I hope that you remember about this. 120 plus 120, and now plus 150M plus 135M, okay? This is what we have. Then, how can we solve this? Remember, each one of them pays 120. So if we add both amounts, we have 240 plus the addition of this, 285 with the variable m. So I can eliminate the parentheses now. I don't need the parentheses. So this is the expression that I have for the monthly deposit that they do in the for the joint account, okay? Sophia's deposit and Ollie's deposit. This is for Sophia. I'm going to write Sophia and Ollie. Okay, only for you to know that it's different. This is the exercise that says try it. You write the expression in the blank space you have in the page, okay? You have this space to write. Yes. in 3 lines like I solved it, so you are going to have it correctly in each line. This is the first line, the second one, and the third one with the answer. Explain why the initial deposits and monthly deposits are not combined into one term. Okay, remember the initial deposit is a initial fee. They only pay once. So you cannot add again with the variable because the variable is monthly. So we need to separate when something has a variable and when it doesn't have any. Okay. Now that the example 1 and 2 are clear, we can continue with the example number 2. Then I'm going to copy the example 2. In the example 2, we need to add expressions with more than one variable. So add expressions with more than one variable. Okay, and what is the expression that I have? I need to read the example to understand what's happening in the problem and why I need to find. So Cindy spent $125 on ingredients for muffins and $92.40 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. So we have two different values for the variables, right? One variable is M and other variable is B for the bagels. So Cindy's cafe, the muffin has a cost of $2.40 and the bagel is one cost $1.80. So the muffin, we are going to write the equation like appears in the book, but we read together. The muffin income, 2.40 multiplied by M. Remember, each one costs 2.40, but we don't know how many of them they are going to buy, for example. So we multiply by the variable M. When I don't know the exact number of something, I can use one variable, like in this case. So 2.40, I'm going to copy the equation so you can see it. Minus 125. Why they subtract this? Because this $125 is the cost for the ingredients. So they can win this, the number of muffins that they sell multiplied by the price, but you need to subtract what you spend to cook the muffins, okay? So they subtract the number of dollars that they spend for the ingredients. And for the other one, the bagel income, 1.80. I'm going to separate the equation so you can see it better. 1.80, sorry, this is B because it's the bagel, minus the cost of ingredients, that the cost of ingredients for the bagels are $92.40, minus 92.40. And what can I do in this case? I need to add, but remember that I have different variables. So I need to have at the end the variable M and the variable B. What terms can I combine? I can combine these two terms because they don't have variable. So if they don't have variable, they are similar terms and I can combine this, okay? I hope that you remember about that when we practice to separate the terms with variable and not. So I separate using the parentheses now. $2.40M, I'm writing the equation that I have on the top, minus 125 plus the other part of the equation, that is for the bagels, 1.80 minus 92.40. Okay. Then what I need to do in this case is to separate the terms that I can add and the terms that I cannot add. In here is missing the variable B, okay? So I have 2.40M plus 1.80 B. Remember, I cannot add this because they have different variables, okay? One variable is M and the other variable is B. So I cannot add or subtract if they have different variables. I can do it like in here, that I have the same, okay? Or like in here that they don't have any variables, so I can subtract or add. So in this case, I can add negative 125 minus 92.40. And what is the result for this? Is negative 217.4 because we use the commutative and the associative property, okay? Commutative and associative property is only to show you that we can move the terms depending on what we need, okay? According to the numbers that we need to work with. So at the end, we obtain 2.40 M plus 1.80 B minus 217.4, okay? So the expression represents the profit from selling the muffins and bagels. They sell the muffins and bagels, and they have an amount of money that they earn, but they need to subtract the cost of the ingredients because it's a they spend money to buy the ingredients, so they don't have all the money for them, okay? They need to pay for the ingredients. In the number 3 is only to add more complex expressions, but you don't need to be scared about this because it's the same. We associate the same variables to add or subtract. The idea is the same. If you understand the idea how to solve this kind of problems, you are not going to have anything that affects you. 1 over 2x minus 3 minus 2y. Okay, and we need to add this with the other expression that we have in here. The other expression is 1/4 minus 2y plus 5. So this is the expression that we have. I'm going to move it maybe in here. And I'm going to write that this is the example 3. Add more complex expressions. Okay. And if we add this, how can we solve? I'm going to separate the variable x in one parenthesis, the variable y in another parenthesis, and the terms that doesn't have any variable in other parentheses. So 1/2 x, 1/4 is with the variable x, right? Yes. So in here I have 1/2 x plus 1/4 x, okay, plus, and I add this part, negative 2y plus negative 2y. I need to expand this more because I don't have space enough. Okay. Plus negative 2y plus negative 3 plus 5. Okay, look that I only separate. Maybe in this you can see it difficult because we have many parentheses, but if we eliminate the sign and we eliminate the other parentheses, we have this, negative 2y minus 2y, okay? But we write everything only to show the order. We add because they have the same sign. So that's what represent in this case, okay? And when we solve this, you already know how to solve the operations with fractions. 1/2 plus 1/4, I obtain 3/4 x plus negative 4y plus 2. You can try the exercise again, okay, and solve it, okay, so you can be sure that the procedure is correct. But remember that it's supposed that you already know how to solve the exercise. I'm only showing you that you separate with the variables, depending on the variables, and you add or subtract. So the final answer is 3/4 x minus 4y plus 2. Okay, so when you start solving this, you can say, oh my God, how many parentheses? But it's the same because we separate according to the variable and we solve step by step and we obtain one expression like this. Okay, it's already simplified. Then this is the result for the variable x, y, and the numbers that doesn't have a variable, that is the number 2. So guys, I think that I'm going to finish in here. I'm going to finish the class.